Poisson distribution example problem 5. This is a two-in-one model. We solve one problem in two ways. One is binomial distribution case. Another one is equivalent Poisson approximation case. Now the problem is, it is known that the probability of an item produced by a certain machine will be defective is 0.05. If the produced items are sent to the market in packets of 20, find the number of packets containing at least exactly and at most two defective items in a consignment of 1000 packets using number 1 binomial distribution, number 2 Poisson approximation, 2 binomial distribution. So here X is random variable. First category, it is binomial random variable. For second, it is taken as the equivalent Poisson random variable. Now, the total problem is given as a diagram. First, we take binomial case. In this data, number of packets contains 20 items. So, this 20 is number of trials, small n, and p success probability defective item uh, to be an item to be defective, the respective probability is taken as the success probability, which is small p 0.05. So obviously q is 0.95. The total count, we are talking about 1000 such packets. So it is taken as capital N frequency, that is 1000. Now write the binomial distribution's probability mass function. It is p of x equal to r equal to ncr p power r q power n minus r. Using this binomial probability mass function, we find each category's answer. First, we are taking the three categories. One is exactly 2, another one at least 2, and the last one is at most 2. Exactly 2 means directly x can be taken as 2 equal to 2. At least means from 2 it can be at most, maximum 20 defectives from 2 onwards. So x is greater than or equal to 2. Third category is at most 2. That is, the maximum number of defectives should be 2. So it may be either 0 or 1 or 2. It do not cross the number 2. Defective items maximum number is 2. These three are going to be solved by binomial case. First, we take probability of x equal to 2, exactly 2 defective case. Using the probability mass function, we write uh, 20 instead n and 2 instead r. So 20c2 0.05 power 2 and 0.95 power 20 minus 2. Simplification and give the answer 0.1887. This is the probability for having chance exactly 2 defective in a packet of 20 items. Now the actual question is, for 1000 such packets we have to find the number of packets having exactly 2 defectives. So we should multiply this probability value by 1000, and it is 188.7, and rounding it will be 189. Now case number 2 is at least 2 defective case, that is probability of x greater than or equal to 2. This means from 2, the defectives may be 3, 4, etc. up to 20 items, so 20 defectives. But it is tough to calculate everyone and add. So we are talking about the complementary part, that is 0 defective case and 1 defective case. They are not included in this case. So if we calculate that area and subtracting that values from total probability value 1, we get the answer. As we know in the previous discussions, 1 minus of p of x equal to 0 plus p of x equal to 1. So calculating using the probability mass function and subtracting both the values from 1, we get 0.2641. Multiply by 1000, we get 264. Now the third case is probability of at most 2 defectives. So maximum number of defectives should be 2. So here 0, 1, 2, 3 cases are coming under the this title. So we get respectively the values as per previous calculations we can use, or directly calculate it again. It is 0.3585 plus 0.3774 plus 0.1887. After adding, we get 0.9246. Multiplying by 1000 packets, we get 925 nearly. So all the calculations parts are finally per number of packets. So it should be rounded. So nearly answer may be approximately, but it should be given as a uh, positive integer because number of packets we are talking about. Now the Poisson distribution case, we use Poisson as a limiting form of binomial. So the binomial category entities n and p are taken as the product here because lambda is np. Multiplying 20 and 0.05 we get 1, lambda is 1. Write the probability mass function we know and use it in each case, we get the answer. Probability of x equal to 2 is e power, we know the formula minus lambda, lambda power r by r factorial. Here r is 2 and lambda is 1. So entering the values e power minus 1, 1 power 2 by 2 factorial. It is 0.1839. Multiplying by 1000 packets, it is 184 nearly. Now second case is probability of x greater than or equal to 2. As usual, we take the complementary parts and subtract it from 1. We get 1 minus of uh, probability of x equal to 0 plus probability of x equal to 1. Substituting r equal to 0 and r equal to 1 respectively in each of the case, we get finally 1 minus of e power minus 1 plus e power minus 1. So subtracting that values from 1, we get 0.2642. So n into, that is multiplying by 1000, we get the answer 264 nearly. Now the last case, at most two case, probability of x less than or equal to 2. It is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So respectively apply r as 0, 1, 2 in the probability mass function of Poisson distribution, and already we know lambda is 1. So we get e per minus 1 first term plus second term e per minus 1 and third term is e per minus 1 by 2 factorial. After calculation we get 0.9195. uh, for 1000 packets we have to multiply this probability value by 1000, we get 920 nearly the number of packets out of 1000. The defective items with at most 2 count is here 920. Identification of small n and then p and finally capital N is the most important part of this problem, and binomial and Poisson respective probability mass function formula also important. Then we can easily calculate any such problems.